So the problem is we need to find out the subsets of this number. So subsets will be all the combination of these numbers. So 1, 2, 3, 1 with 2, 2 with 3, 1 with 3, 1, 2, 3, and empty 1. So we will discuss two solutions. One is iterative and one is recursive. So we'll discuss firstly recursive one. So this is the problem, and we are keeping the result in this variable with the empty array firstly. So our idea is like we're gonna choose this element first and then we will explore the rest over elements. So let's choose this one element. So I will keep this element in this variable n and we'll explore other rest over array, which is 2, 3, right? Sorry for the writing, by the way. And then again the same process. So now we have first element 2, we're gonna choose this one and we're gonna explore the rest over element, which is 3. Cool. And now again the same process, we're gonna choose 3 and the left over array is blank. So this is our basically base condition that whenever we reach to the empty array, we're gonna return back. So when we're gonna return back, we need to process something, and that is we need to process this result. We're gonna iterate this result and append this 3 with each element, and that result will be pushed to this result. So if we append 3 with each element, then this will be 3, right? It's just a append, and then we're gonna push this to the result. So the answer will be this. Okay, so now we come to here and then we're going to return back here. So we have 2 as a chosen element and we have a result this. So we're going to iterate over each element. So the elements are empty array and the 3, and we're going to append 2 with each element and we're going to push everything to this result. So the first, it will be 2 if we append 2 in the first element, and if we append 2 in the second element, then it will be 2, 3. So now the result will be this. So we will go back to this point where we have n is equal to 1, which we choose at that point. So we're gonna iterate every element and we're gonna append this 1 to every element. So it will be like 1, 1, 3, 1, 2, 1, 2, 3, and we will push everything to this result. So the answer will be this. So now we are left with nothing, so we're gonna return this result. So that's it for the recursive part, and it's very similar solution exists if we do with iterative. I will show you the code now and then we will discuss the time complexity and the space complexity of this solution. So let's go to the code. So this first one is a recursive solution. So taking the same example we took earlier. So the result is assigned to this variable with the empty array in the array, and we are exploring the numbers. We are calling this method from here. So numbers are 1, 2, 3 initially. If the numbers are empty, we're gonna return the result this as it is, right? But in our case, the result the numbers is not empty, it's 1, 2, 3. So it's gonna shift the element. So shift is just a Ruby operator which will remove the first element from the array and will keep other elements intact. So I'm coding in Ruby as of now. So n will be 1 at the first time. So shift is just doing this and then exploring other numbers, which is 2, 3 now, and then iterating each element in the array and adding, or we can say appending the array in this current array. So that's how this recursive will work. It's very simple. And the below is the iterative one. This is more simple. So it's just iterating over the numbers. So basically if you have 1, 2, 3, So 1, 2 and 3. So first element is so n is equal to 1 at the first time, and the result is empty. So what it will do? It will do result is empty plus 1, right? This is what we have written. R is empty for at the first time, right? And the n is this. So the answer of first is empty and 1. Cool. And now n is equal to 2. In the loop at the second phase, n is equal to 2, right? And we have all the elements is empty array and the 1. So our answer will be 2 and this is 2, 1, right? Or because we are okay, sorry, it will be 1 and 2. And because we already have these element array empty and then 1 and appended will be 2 and 1, 2 will be the answer. And similarly we will see if n is equal to 3, so it will also iterate the result and will assign everything to the result. Basically it's appending, right? So what is the time complexity? So if you have one element in the array as an input, so the combination will be this empty array and the 1. Sorry, basically the subsets are these. So which is count is 2, right? So which mean 2 power n, right? Which mean 2 power 1. So which is 2. Okay, let's see other example. If we have 1, 2, so we will have this empty array 1, 2 and 1, 2, which is 4, right? So 4. So we can say that 2 power n is 2, which means 4. So we can see that the complexity is 2 power n. Good. And if we see the space complexity, we are keeping everything in the result variable and all these values are residing in the result variable, so the space and the time complexity is same. So that's it guys for this video. If you liked it, please share, like and subscribe. Thanks for watching.